All right, so today we're going to be talking about Chapter 5, Lesson 4. This is called Polygons and Angles. It says here that the sum of the measures of the interior angles of a polygon is represented by this equation, n minus 2 times 180, where n is the number of sides. So the equation would be S. This here is the sum of interior angles is equal to n minus 2 times 180. Now this n minus 2, remember n is the number of sides that a polygon has. So if it's a 5-sided figure, you'd put 5 in for n. If it was a 7-sided figure, you would substitute 7 in for n. But this n minus 2, this also talks about the number of triangles that are needed to create that shape. So, for example here, this is a triangle. There are 3 sides, and it takes 1 triangle to make that triangle. 3 would be n in this case. 3 minus 2 is 1. On a quadrilateral, this is not a square, but on a quadrilateral, there's 4 sides, and it takes 2 triangles to make that. So 4 minus 2 is 2. And then times 180 to get 360. On a 5-sided shape, this is called a pentagon. 5-sided shape, so we do 5 minus 2, which is 3. And it takes 1, 2, 3 triangles to create that pentagon. Same thing with a hexagon. That's a 6-sided shape. 1, 2, 3, 4, 5, 6. It takes 1, 2, 3, 4 triangles. And 6 minus 2 is 4. So let's look at the first example here. It says, example 1, find the sum of the measures of the interior angles of a shape with 13 sides. Not an incredibly imaginative name, but a 13gon. So the equation would be S equals n minus 2 times 180. N is 13. So we do 13 minus 2, which happens to be 11. And then if you do that multiplication, 11 times 180, so S equals 1,980 degrees. And that would be the sum of those interior angles, all added together. Now, we don't know what the angle measurement of each individual angle is. It does not say that this is a regular polygon. We'll talk about what regular means too. But it doesn't say that. But all we know is on a 13-sided figure, the sum of those angles on the inside, the interior angles, is 1,980 degrees. All right, example 2. A designer created a new logo for a bank. The logo is shown below, drawn by me, so not the best drawn, but it says find the measure of one interior angle in the regular pentagon, which means we're going to be looking for one of these 5 angles. The word regular, what this means is all sides the same length, and all interior angles congruent. Which means it doesn't matter which one you find because they're all the same. But the formula is still going to remain the same. So we have n minus 2 times 180. There are 5 sides in a pentagon, so n is going to be equal to 5. And 5 minus 2 is 3. Now, 3 times 180 degrees is going to get you 540. That's the sum of all of the angles added together. Now, in this case, there are 5 angles. And if they're all the same, because it says regular, we can take this number here, 540, and we can divide that by 5, because if all of the angles added together is 540 degrees, and each angle is exactly the same, we can simply divide the sum of the angles by the number of angles. So each angle is 108 degrees, because 540 divided by 5 is 108. All right, last example here. We're talking about exterior angles. And exterior angles are really nice because the sum of all of the exterior angles of any polygon, 1 or 3 side, 4 side, 5 side, 32 side, 400 billion sided figure, they will all add up to 360 degrees. Now, how you determine an exterior angle is you draw each side of the polygon, and then you extend one of the sides out, and the angle that's formed there is an exterior angle. So this side length is to here. We extended the line, created this angle for angle 1. This side we extended in this direction to make angle 2. We extended this side to make 3, this side to make 4, and this side to make 5. So if I add up all of those angles, I get 360 degrees. Now, the nice thing is, too, if we have a regular polygon, again, that means all these sides are the same, all the interior angles are the same. So then, by extension, all of the exterior angles are congruent to each other, not to the interior angles. The exterior angles are congruent to each other. So then, all we would have to do is take 360, which is the sum of all of the exterior angles, divide by the number of sides there are, and that would be the measure of one exterior angle of a regular polygon. So in example 3, find the measure of one exterior angle of a regular hexagon. Hexagon has 6 sides, which means that this n is going to be 6. So my equation is really 360 degrees divided by the 6 angles that there are, because there are 6 sides, so 6 angles. And this means each angle is 60 degrees. All right, that is the end of lesson 4. If you have any questions, please let me know.